everyone. Laxmi Akkaraju, Senior Vice President of Strategy at Cognite here. It's really great to be back at a GSMA conference. I worked for the GSMA for several years, and the Eurasia M360 was always one of my favorites. So I really wish that I could be in Moscow with you guys right now, but I hope another time. As mentioned, today I work for Cognite, which is a global software technology company, and we work with heavy asset industries to help them optimize their production for both profitability and sustainability. And we leverage machine learning and artificial intelligence in our products to gain speed and to gain accuracy. So today I want to talk a little bit about how we're able to leverage these technologies in heavy asset industry and how much AI we're really able to use in industry and how. So before I start, just a little bit more about Cognite. We were established in 2017, and today we are the world's leading company in the area of industrial data ops. So what is industrial data ops? As you know, digital transformation is all about responding to increasing variety, volume, velocity of change. And we're increasingly hearing that digital transformation is a data problem. So executives across industries acknowledge that data is the challenge, and that manual data collection, data quality reported are some of the biggest challenges with getting the data right. So data ops is a methodology that defines a new collaboration model between data producers and data consumers so that we can accelerate digital transformation and deliver faster value by enabling reliability, reusability, repeatability, and also automation of data. So at Cognite, we've worked with several large companies. We have a track record of successful operationalizing projects from leading industrial companies like BP in Saudi Arabia, Saudi Aramco. We're headquartered in Oslo, but we have offices around the world with over 600 employees. And we have global partnerships with Microsoft, Accenture, and we're also currently backed by two of Silicon Valley's prominent venture capitalist firms, Excel and TCV. And in fact, this last spring, we were named as the first Norwegian unicorn. So we're very proud of that. So unarguably, the power of data for industry is immense, but it's not easy to liberate this power. So our experience in industry has helped us to understand the pain points for both operational and IT leaders. And these include, extracting data from complex infrastructure and system architects. It also includes the unique physics of industrial operations for data analytics, and of course, data volume, quality, and transparency challenges. So the greatest opportunity that we feel that lies in solving the data problem, and it requires facilitating AI workflows and data flows between IT systems and OT systems, so between the virtual and the physical systems, that would give customers a timely and accurate data to build on. And we also believe that codifying industrial, I'm getting feedback, is it okay over there? So codifying industrial expertise into software to help industrial operations draw solid insights from their data and unlock opportunities in real time. Our flagship product is Cognite Data Fusion. And what Cognite Data Fusion is, it's an engine that liberates data from all sorts of sources. So from sensors, from meters, from engineering drawings, from the ERP data that's created. And we create relationships between these disparate data sources using hybrid AI, which is a combination of machine learning and deep industry knowledge, as well as simulation. And this is a process that we call contextualization. So included in our platform is we have open APIs and SDKs that ensure that data can easily be consumed in a form that's easy to understand either by humans or machines, and that we can create insights that help our customers to, in many categories, to increase production optimization, to accelerate predictive and real-time maintenance, to run facilities remotely, to enable robotics and other automation, and also, very importantly, to improve health and safety conditions, as well as reduce environmental impact. So let's look at a couple of use cases that we have in industry. So the first one uses AI and computer vision. So vision data is anticipated to be a major driver of Industry 4.0. And it's a transformation that's expected to deliver between $1.2 and $3.7 trillion in value by 2025 worldwide, according to McKinsey. Of course, there have been improvements in image quality, size and cost, even size and cost of simple cameras, and also continuous improvements in machine learning algorithms, sensor price points and bandwidth in cloud and edge computing. And all of this has helped to really unlock the potential of computer vision in industry. So there are initial use cases like computer vision guided robots, and they're beginning to join the production floor in many industrial settings. When we see these use cases, we see benefits in autonomous inspection in remote or high risk areas. We see benefits in 3D visualization because you can have daily or continuous scans of the site, keeping the 3D model up to date. Asset tracking is also very important, especially when there are movable assets. So on this slide, you see a picture of our robot, which we call Spot. So if I look at the first use case, so obviously fully autonomous unmanned facilities industry are still not there, but we are moving closer to that vision. So in this use case, we deploy Spot at SCARV, which is a floating production storage offloading unit. And for remote, high risk, restricted sites, robots are deployed, and it helps to augment the operator's work. They handle the inspection rounds. They do daily scans of the assets and installations. They update the 360-degree images, and they keep the 3D models up to date and trustworthy, so the remote operators know what they're looking at a given time. So in this case, this robot captures vision data, and then CDF, our product, then creates a photogrammetry model to update the digital twin. And of course, the sensor data is captured and contextualized by detecting tags and reading gauges and converting the vision data into time series data. And probably most importantly, Spot can also detect abnormalities. So if there's a gas leak or if there's any slow changes such as corrosion. So this example was pretty straightforward because the use of AI in analyzing and interpreting image is a use case that's pretty broadly used both in industrial environments, but also in a lot of other environments like surveillance for public safety or military use cases. But I wanted to look at a second example of AI, and this is an example where we use hybrid AI in heavy asset industry, because heavy asset industry is rich with data, both historical data and real-time data. So the data is there. So you might think, could we simply deploy analytics and AI and experience kind of a transformative, disruption in industry? And in one way, you would think that you can, but the fact is that heavy asset industry and industry in general is still on a learning curve. And when we look at specific industrial operations and technologies, we find that it's much more difficult to use a pure data-driven AI approach to data analytics. And we become much more dependent on hybrid AI. So let's look at what hybrid AI is, what we mean by that. So simply put, there are two fundamental methods to analyze predicted impact behavior of an object, whether it's an asset or equipment or a process. So we can either look at the historical behavior, identify a pattern, and predict its behavior in the future based on the data. And this is the data-driven or AI approach. Or we could simulate an object, describing its behavior by a mathematical model based on the best knowledge of physics. And this is a physics-based modeling approach. And purely data-driven AI or machine learning is seen as the most attractive because it's scalable, but it's failing to gain full acceptance with industrial operations because AI is seen as a black box. And we're talking about industry and engineers and operators of equipment whose culture is rooted in the engineering sciences and also very much accustomed to zero risk tolerance for critical systems. So black box is just a very challenging approach for them. And of course, also in many cases, there's not enough empirical data points to train the ML models because obviously extreme conditions may never have been experienced or the data wasn't captured if it was experienced. But as I said, the advantage of AI is that it's scalable and cost efficient, but then these are some of the disadvantages. Now we look at the physics-based modeling, it's more established, but it's less hyped because it's well known that this approach is still not as scalable. And the modeling is costly because the simulators may not be efficient with big data in real time. The simulators are built, of course, using robust mathematical foundations and are transparent and unambiguous. And also, we can try to get data points to simulate extreme conditions. And like I said, both these methods have pros and cons. But in reality, what we do then is we try to use a combination of this. We use the hybrid AI model where we take the blend of physics and AI analytics that combines the robust mathematical foundation of physics-based modeling with scalability and pattern recognition capable in AI. And it really provides us the best of both worlds. It provides a more informed reality of AI in industry. So if we quickly look at one example of this. So in this example, a smart monitoring system it's a smart monitoring system, and we use a hybrid AI approach to find a faster way to identify oil in water contamination. So for our oil and gas customers, disposing of produced water to the sea is a challenge. One, because of recurring oil concentrations that are above regulatory limits, and that results often in significant costs, and it also results in a slowdown of production. And the causes of this kind of high concentration range from a multitude of factors. So even the most sophisticated process simulators would require tremendous computational resource to be able to model oil and in water concentration. So in this case, the only realistic approach is to leverage the computer power to find hidden patterns and relationships using both live and historical data. And here, physics and domain knowledge are included by modeling key physical processes and enriching the data set. So the outcome of this hybrid ML model is a smart monitoring system visualizing the data for water contamination and identifying the root cause for worst actors related to high oil and water concentrations. And of course, this allows for timely and targeted intervention. And as a result, we've seen one of our customers, for example, has decreased the time spent on mitigation and has saved around $6 million per year for the company. Another one of our customers has reported saving around $12 million in using this technique. And of course, the money savings is only one side of the coin. The other side is, of course, the positive environmental impact associated with the immediate prevention of inadvertent disposal of contaminated water. So it's really a win-win. So my final slide, just to conclude, basically with these concrete working solutions implemented and scaled, we are really building on our vision of empowering a data-driven future for heavy asset industries, where digital technology, such as computer vision, digital twins, hybrid AI, streamline operations and workflows and help companies to stay competitive, profitable, and sustainable. For industries of the future, profitable growth will only happen if they are focused also on their sustainability. And we believe that digital systems can do much more than simply streamline the process. We believe that this technology and technologies can help to cut emissions, reduce waste, and limit environmental harm when data is extracted from their disparate silos and used broadly across the operations. So at the end of the day, our motto is making data do more, frees up humans to do what they do best, to innovate. Thank you very much.